Okay, let's just jump right in. I want you to completely forget everything you think you know about power. What if I told you that the next huge energy source, well, it isn't something we have to mine or burn or even capture from the sun? What if it's been all around us this whole time? Right here, in the very air we're breathing.
Now, seriously, just think about that for a second. Your phone, your watch, your fitness tracker, what if they just work all the time? No more desperately searching for an outlet, no more lugging around those heavy power banks. What if they could just power themselves, like continuously, 24/7?
I know. It sounds like something straight out of science fiction. But this isn't fiction. This is about a truly remarkable series of breakthroughs that are actually turning the invisible water vapor in our atmosphere into a clean, constant source of electricity. So, the big question is, how is this even possible? It feels a little like a magic trick, right? But the science behind it has actually been hiding in plain sight for centuries, in everything from massive thunderstorms to volcanic eruptions.
So there's a scientific name for this, of course. It's called hygroelectricity. Basically, it's just the natural charge that builds up on water droplets. And get this, it's the exact same force that creates the absolutely massive electrical power you see in a lightning strike. The challenge, has always been, how do we tame that incredible power? And this quote just illustrates the breakthrough perfectly. As researcher Jun Yao puts it, scientists have essentially figured out how to build a tiny, predictable cloud in a box, one that doesn't produce lightning, but a steady, harvestable electric current. It's brilliant.
Okay, so we're building a cloud in a box. Awesome. But how does that actually work? What's the secret ingredient here that lets us just pull electricity right out of humid air? Let's dig into the mechanics of it. All right, so the whole thing hinges on this one crucial point. You have to create a charge imbalance. It's just like a regular battery, right? You've got a positive end and a negative end. These new devices do the same thing by creating an electrical difference between a wet side and a dry side. And that difference is what gives you voltage.
So how do you create that wet versus dry imbalance? Well, researchers over at UMass Amherst found the secret, and it's in a property called the mean free path. The easiest way to think of it is this. It's the average distance a single water molecule can travel through the air before it bumps into another one. And they figured out that the magic number for that distance is right around 100 nanometers.
And they took that number and used it to design this incredible microscopic trap. So here's how it works. You start with a material that's just filled with these tiny, tiny holes, nanopores they're called, and each one is smaller than that 100 nanometer path we just talked about. Now, when water molecules from the humid air fly in, they can't help but smack into the top edge of the poreway, way more than the bottom. And this constant bumping, this bombardment, it creates a charge imbalance, a buildup right there on the top surface. And boom, just like that, you've got a battery that literally runs on humid air. Now, here's the most mind-blowing part of their discovery. This generic airgen effect, which is what they call it, doesn't depend on some crazy, exotic, expensive material. We're talking about almost any material being engineered with these nanopores to generate electricity. Wood, silk, plastic, you name it. And this isn't just theory anymore, not by a long shot. Teams all around the world are building real devices based on these principles, and they're taking two very distinct and honestly equally fascinating paths to get there.
So on one side, you've got the UMass team, and they're focusing on the universal physics of these nanopores. That's the generic effect. And on the other side, there's a team at the National University of Singapore, or NUS, and they're using a super clever recipe of specific materials, kind of like a chef crafting the perfect dish. So the UMass approach, which you can see in this rendering, first proved this whole concept using protein nanowires they harvested from a microbe. But remember that whole generic effect thing? Well, their newer discovery means they can now apply this principle to almost any material, which just gives them a huge toolkit for building these air generators.
Okay, now let's check out the NUS team's fabric battery, because it is just brilliantly simple. You can follow the steps here. They take a piece of fabric, they coat it with carbon, and then they treat one end with a special gel made from sea salt. The salt, as you might guess, naturally pulls moisture from the air, and that breaks it down into charged ions. Those ions then travel across the fabric, and that's what creates an electric field. It's a really elegant, low-cost solution using sustainable stuff. So the science is cool. The materials are super clever, but does it actually work? I mean, can you power anything with this? And the answer to that is a definitive yes. Just look at these numbers from the NUS research team. A tiny patch of their fabric, just a little bigger than a postage stamp, can produce 0.7 volts for over 150 hours. That's more than 6 days. And that's from a single exposure to humidity. Incredible. And guess what? It's scalable. The team connected just 3 of these little fabric pieces together and got nearly 2 volts. That's actually more than a standard AA battery. And it was enough to power a small alarm clock. The potential to stack these or combine them in different ways is just huge. And here it is. The proof, plain and simple. This isn't some computer simulation. This is a real device made of those protein nanowires, generating a measurable voltage right here on this multimeter. You are literally looking at electricity being made from thin air.
So what does all this mean for the future? Well, if this technology can scale up, it could fundamentally change how we think about energy. We could move from these big, centralized grids to power that is generated everywhere all the time.
I mean, the advantages here are just staggering. Unlike solar or wind, this works 24/7, indoors or out, rain or shine. It works in a rainforest, and as the UMass team found, it even works in incredibly arid places like the Sahara Desert. And it can be made from cheap, abundant, and non-toxic materials. It's a win-win-win. The list of potential applications feels almost endless. We're talking about self-charging wearables that can be powered by your own skin's humidity, phones that never, ever die. Researchers are even talking about mixing this technology into wall paint to help power our homes, or creating generators that can provide electricity anywhere, completely off-grid. Of course, we have to be realistic. We're not quite there yet. The biggest hurdle right now is efficiency. At the moment, these devices are converting less than 10% of the available moisture energy into usable electricity. So improving that number is the key challenge researchers are laser focused on to make this a widespread reality.
But the basic principle, it's been proven. The path forward is becoming really clear. And it leaves us with this one just fascinating question to think about. After centuries of digging deep into the earth and looking up to the sky for our energy, could it be that the most abundant, the most consistent power source was right here, all around us the entire time?